Pratap from IT Roorkee, and we would be continuing discussing our top interview 150 series of questions on Leetcode. And our today's question is, our today's question is construct binary tree from preorder and inorder traversal. So the question states that given two integer arrays preorder and inorder, where preorder is the preorder traversal of binary tree and inorder is the inorder traversal of the same tree, construct and return the binary tree. Example number 1 is this: 3, 9, 20, 15 and 7. So this tree we have to return, and like we are given pre-order as 3, 9, 25, 15, 7, and in order as 9, 3, 15, 27. So pre-order is first the value comes, then the left child comes, then the right child comes. So we can check in the reverse manner. So if we write down pre-order of this tree, then it will be 3 at first, because value comes first, so 3 will come first. Then left child 9 will come first, then right child 20 will come, then left child 15 will come, then 7 will come. Similarly for in order, first left child occurs, then value occurs, then right child occurs. So for this, first left will occur, so 9 will appear first, then 3 will appear, then it will come on to this. So for this, first left will appear, so 15 will appear here, then 20 will appear here, and then 7 will appear here. So the tree which we have written, that is a correct tree, and it is the representing the pre-order and in-order traversals. Example number 2 is like pre-order is given as -1, just one root node is given in this case, so we will return that. Pre-order dot length can go from 1 to 3000, so this length, array length, can go from 1 to 3000. In-order dot length is equals to pre-order dot length. So these two lengths will always be equal, because these contains the total number of nodes, and total number of nodes would be some number n. And property pre-order I comma in-order I varies from values varies from -3000 to 3000. So these values, so node values will go from -3000 to 3000, and pre-order and in-order consists of unique values, so all are unique values. Each value of in-order also appears in pre-order, so each value obviously would appear in pre-order as well. And because they are representing the same nodes, but they are in some different structure or order, we can say. Pre-order is guaranteed to be the pre-order traversal of the tree, and in-order is guaranteed to be the in-order traversal of the tree. So this is given like this means that our input which is given to us, that is a correct input. So this is the question, and in order to solve it, what we are going to do is we will start iterating from our root, and when we will start iterating from our root, first of all we will have to create a map, and in that map we will store like for in order array we will store what is like key would be stored as this value, and value will be stored as the index of this array. So for 9 0 would be stored, then for 3 1 would be stored, then for 15 2 would be stored. So in this way we will define one map which will keep a track of like which element in order array is present at which index position. And then we will start iterating our this root node, and like while one observation which we should make here is like this first element will always be the root of, like the first element of pre-order will always be the root, because this is because in pre-order first the value appears, so this is a root, and now we need, now there's some part would be the left subtree and some part would be the right subtree. Now in order to know how many nodes are there for the left subtree, we will find out what is the position of this 3 in the in order. So in the in order the position of 3 is at 1, so this means that there are one number of element which are before this 3. So this means that all the number of elements in the left subtree of 3 are 1. So this 9 belongs to the left subtree, and 20, 15 and 7 belongs to the right subtree of 3. So this is a keen observation, and let's go to the code then how we are going to implement it. So we are given this struct tree-node definition where int value is given, tree-node star left and tree-node star right pointers are given, and constructor are also given. Then we are given this function which we have to implement, tree node star build tree. We are given these two arrays, pre-order and in-order. Then we are defining our map, and then we are defining n as the pre-order dot size. So n will be the number of total nodes in our final tree, and then we will start iterating our in-order array, and we will store its values as key in the map and its index as value of this map, as we had discussed before. And then we will define one helper function, and we'll pass this pre-order and in-order, and we will also pass this map, and then we will pass this 0th index and n minus 1th index for this pre-order, and 0th index and n minus 1th index for this in-order. So inside this helper function we have this pre-order, then this pre-l, then this pre-r. So this is pre-order left and pre-order right, and this is in-order left, in-order right, and map. And then we are checking if pre-order right is less than pre-order left, then we will return null. And similarly, if in-order right is less than in-order left, then also we will return null. And then we are defining our root as new tree node pre-order pre of l. So first of all, we are passing 0 as pre of l. So this 0th index would be assigned root node. And then we are calculating what is the index of this root element in our in order. So through this map we can get the index. So through index we will know how many elements are the present in the left subtree of this current root node. So we will define root dot left as helper. We will use recursion. Then we'll pass this pre-order, and for left subtree we will pass this pre-order l plus 1. So for 0th node we will pass this 1 as the starting index, and ending index would be this one, this only in this case. So in this way we'll pass down what would be the elements for the left subtree, and similarly for in order also we'll pass the corresponding indexes. Those would be starting index in order left and int minus 1. Similarly for root dot right we will pass for pre-order we will pass this. So this is pre-order l plus int minus inl plus 1 and pre-order r, and for in order we will pass this. So this is same int plus 1 and in r and m. So in this way our left subtree and right subtree would also be built using the recursion, and then we will finally return our root, and then we are returning this helper function. So let's try to run it and see whether this solution is working fine or not. So yeah, this is getting accepted here. Let's try to submit it as well. It is taking time. So yeah, this is getting accepted here. So this solution is working fine. I will attach this code solution in the comment section of the video, and I will also attach this problem link and problem description in the description of the video. So like this video and subscribe to my channel for more such top into 150 series of questions on Leetcode.